Okay, let's fire things up one more time. Today we're going to be taking day two of continuity, and what we need to do on this is we need to consider that this is the intermediate value theorem. Now, anytime you get something that actually has a name in math, probably has some sort of significance. Now, I will tell you right now that most of the time you're going to see this written as the IVT. So, if something has a name, it's kind of significant. If it has an abbreviation, trust me, you want to learn this. So, on the intermediate value theorem, or the IVT, well, I could read it to you, but I'm not going to because what it's saying is I've got some limitations. I'm going to say in between A and B, and in between F and A and F of B, okay, is what I'm considering. So if I have, first off, it has to be, well, here, first, let's start with the basics. I need to tell you that this is not something where you end up solving. It's an existence theorem. It doesn't tell you that you can solve anything, but for our purposes, um, we just know that a solution exists. And that's really what we're trying to do often is just prove that there is some sort of solution. Now, how do you go about, doing your analysis on this? Well, what we end up saying is we start off by going through the following. And we say that it has to be a continuous function. Okay, so we'll start off and I'll come up here and I'll highlight that it's a continuous function on a closed interval. Okay, so in between A and B, it's got to be a closed interval. It can't be open. In other words, A and B have to be defined. Okay, and then it's saying that the function has to take on every y coordinate in between this one and this one. Now, I actually had a student a few years ago say, hey, Mr. Johnson, can I just call this the no duh theorem? Because this is kind of obvious. You just told me that it's a continuous function. Yes, I did. So therefore, if it's continuous, it means that, yeah, every y coordinate has to be represented. And what we're going to say is that for any y coordinate that's between A and B, there is some value C for that. Now, if you have any discontinuities, it may fail. Also, I can tell you that you could have multiple solutions for this, but we're only considering if it actually works. So, next up, we're going to take a look at this, an application of it. And again, this is, well, anyway, just follow me on this one. Is any real number exactly one less than its cube? Okay, so what it's trying to say is this. Is there some value of x that is exactly one less than its cube? Well, let me write that mathematically and say, well, if there's a solution for this, it would satisfy this equation. Okay, so far so good. Now, I am going to have people that are immediately going to say, oh, I need to shift the x over to the other side and I need to factor it and solve. Remember, we're not always trying to solve it. We're just trying to prove that it works. And most of the time, what we end up doing is using some familiar values to help us to get someplace. So let me move this out of the way. Again, I can do something like that. So what we're going to do is we're going to say, well, let's check out some values. Okay, come on. And we'll go there. And we'll say that we can plug in two values, 1 and 2. Now, what happens when I plug in 1 is I'm just substituting 1 into my function, okay? Just subbing it in there, and that gets me a value of -1. And when I substitute in a value of 2, again, same spots, I end up with a value of 5. Okay, and so what? Well, notice what has happened. We've got -1 here, we've got 5 here. You might notice that this is sort of my target value. Does that value lie in between the -1 and the 5. I'm assuming people are going to say, well, yeah, the minute you have that, you can say that there has to be a solution because the function is continuous. Therefore, it has to take on every value in between f of 1 and f of 2, or -1 and 5, so that in between some value, there has to be some value in between 1 and 2. The function has to take on the value of 0. Ta-da! That's the intermediate value theorem. Now, how do you choose the values? You kind of just go with the easy ones because like 9 times out of 10, it's going to be something simple. 0, 1, 2, maybe a -1, something like that. Not anything complicated. So, the other way you can do this is by being given a function and you have to do something to make the function be continuous. This is a slightly different type of problem, but it's also talking about continuity. So here's my example, just like that. It's saying, now let's find the value for j that makes my function continuous. Now, if I'm going to be looking at a continuous function, that must mean that I'm looking for 3x plus 1 to be equal to jx plus 6. And where are we looking? Well, we're looking when we've switched from one equation to the other, but we're still identifying it as 5. So I'm going to say 3 times 5 gives me 15 plus 1 is 6. And then I'm looking at 5j plus 6. So I'm going to say let's subtract a 6 from both sides, which is 10. And so I'm going to say that for my function to be continuous, I need to substitute in a value of 2 there. Okay, not too bad. Other questions that people have? Well, sorry to disappoint you, but once again, short lesson today, folks. So go ahead and dig into your exit slip, and I'll see you in class.